let's try another one here. I'll let you guys try it, so I showed you that one now. And now I'm gonna let you guys try one here on your own without me helping you. Okay, so we got 3x squared plus 5x plus 1 equals 0. Okay, use the quadratic formula. And again, this one isn't going to be nice. You're going to have a square root. You're going to have to break it down. Okay, so it's not a perfect square, but it can be broken down and simplified.
Or just prime already.
If it's prime already, then I guess you don't break it down. Oh, yeah, then you're good. You don't have to break it down. Yeah. Once again, you need to, man.
Oh, grossly. Yeah.
So then you plug in 5 squared minus 4 times 3 times 1. And what number do we get? 25 minus 12 would be 13. And does 13 break down?
No.
And does 5, the 1, and the 6 have anything in common here? When we say the 1, it's the number in front of you that we do not see. No, so then what is my solution? That's my solution. How many got that one right? Raise your hand. All right, good. Are we professionals here almost?
Yeah.
All right, I'll give you one more harder one than that. Okay, and again, so here's the deal. Let me go back to that one quick. Okay, so if I want to actually find out where the actual crossings are on my x-axis, what would I have to do?
Just plug in.
I'd plug it in, right? So I'd go -5 plus square root 13, hit enter, and divide by 6, hit enter. So that's one of my crossings, -0.23. And then I would go -5 minus square root of 13, hit enter, and then divide by 6. And then -1.4 is the other crossing. So those are my 2 crossings here and here. Okay, but on this section, they just want us to leave it simplified like that. Okay? All right, let's do a harder one. And when I say harder, I should say not harder, I should say different. Okay, so now, I'll do, I'll do this one with you.
You need the complex root.
Yeah, so example 4 is what I'm on right now. Okay, now this problem here would actually be a nice problem to do what instead of quadratic formula if we were having the option. Completing the square, right? Because do you see how there's already no number in front here? This is even, so you're not going to get a fraction when you divide by 2. And my c is already the other side. So this is set up for completing the square, but we're going to actually do the quadratic formula. Okay? So to do the quadratic formula, what do you have to do on this problem first step?
Pass it over.
Yep, move the c over so it's equal to 0, right? Set them equal to 0, because we're finding the zeros of the function, which are the x-intercepts on the graph. Okay, so I add my 10 to the other side, add 10 to both sides. Okay, and now can I do the quadratic formula? x equals negative b. What happens with the negative b? It would be negative 6 plus or minus the square root of, what are you going to do in here as well? Parenthesis negative 6 or squared minus 4a. What's a?
1.
A 1. Do you guys see there's a 1 here? C, which is now positive 10 all over 2, and then a again is 1. You guys have that song in your head yet or not yet? Negative, positive 6 plus or minus, gotta get a number here, all over 2. So plug in that discriminant into your calculator for me without the square root. And did we get to that negative 4 value? Does that look right? Okay, now what's the issue with the negative 4 underneath a square root?
Can't do it.
You can't solve it, but it can turn into something. What does it turn into? I. Yes, so this negative will come out, and it turns into an I. And what is now the square root of 4? 2. So 2i is what I'm going to get. So 6 plus or minus 2i all over 2. What's nice about all three of these coefficients?
Divisible by 2.
They're all divisible by 2. So what would my final answer be on a problem like this?
3 plus or minus I.
3 plus or minus I. If you wanted to put a 1i, you could. You don't need to, though. Okay, and I always have the real number first, and then I have the imaginary number second. Let's think about this. What would this look like on a graph? So what's my... Wouldn't touch, right? Is my y-intercept, what is my y-intercept up here? 10?
10.
So 10 is my y-intercept. Smiling or frowning here? Smiling. Okay, now here's the only issue though. I know that since it's imaginary, whenever your discriminant is negative, you're going to get 2 imaginary answers. The problem is I don't know what side of the graph it is. So then on this problem you have to do a table or plug in my calculator to figure out. Because my parabola could look like this, right? Or how else could my parabola look? Just kidding, never mind. I can figure that out. Where's the axis of symmetry looking at my quadratic? My axis of symmetry would be at what here? 3. So then which side is it going to be on? This side. I was thinking it could maybe have been over here. Okay, but because then this is a 3, I know that my axis of symmetry will come through here at 3. And then could you then find the vertex if you wanted to?
Yes.
Yep. Plug 3 back into my equation here. So 3 squared would be 9. 9 plus 10 is 19. And then what does 3 times the negative 6 give me?
18.
Negative 18 plus a 19 gives me a 1. So my parabola actually probably comes more like this, right? Okay, because it has to have a vertex of 3 comma 1. And then if this is symmetric from here to here, wouldn't that be the same distance from here to here?
Yeah.
So you see how sometimes we don't, with the quadratic formula, you could actually graph it pretty nicely using that information here too. So you can do that extra stuff. Okay? Questions on that? All right, I'm gonna have you guys do one more problem I think today, and then we'll be done for today. Okay, so this is the last problem. Okay, and it will give you an imaginary number probably. Okay, so on your paper, find the zeros of the function, or the roots, or the solutions. Correct. So we got 25 minus 48, which is negative 23. Is that right? Okay, so I got negative 23 is 23 prime.
No, yes.
Yes. Now if 23 was not prime, what would I have to do here?
Break it down.
Break it down to perfect squares and also take out a what?
I.
An I with negative comes out and it turns into I out in front. But since the 23 is prime, all I do is bring this out in front and then I have my answer. So I get negative 5 plus or minus I square root 23 all over 6. How many got that one right? Raise your hand. Nice. Alright, that is all I got. You guys got the rest of the day to chillax. Like and subscribe
You.
at the bottom of the page. Is that what I'm supposed to say?
Like and subscribe down below.
Hit that button.